Hello student, welcome to my channel Learn Physics. Today I will be discussing the force and laws of motion. My discussions are first law of motion, definition of force, definition of inertia, momentum, second law of motion, definition of unit of force, third law of motion, conservation of momentum, and finally recoil of gun. So today's discussion will be very important for you. Please like, share and comment on this. And if you are new, please subscribe my channel to learn physics easily. So let's start. Now Newton's first law of motion. A body continue in its state of rest or uniform motion in a straight line until and unless an external force acts to change in its state of rest or uniform motion. Look at this. Suppose this is a stationary body. The force acting on it F equal to 0. So it remains at stationary. Now look at this. This is a body moves with velocity u. Its velocity remains u if force acting on it is 0, that is no force acting on it. Now what happens if force acting on these particles? Look at this. If force acting on this particle, the state of rest changes. Now here velocity changes, velocity may increase or decrease. If small force acting on a large body, then state of rest or uniform motion is not changed. Therefore, from this discussion we can define the force. The force is the physical cause which change or try to change the state of rest or uniform motion in a straight line is called force. Okay? So force is the physical cause which change or try to change the state of rest or uniform motion in a straight line. Now inertia, the property of a body by which a body continue in its state of rest or uniform motion in a straight line is called inertia. Now inertia of rest. Look at this, the property of a body by virtue of which a stationary body remains at stationary is called inertia. Now inertia of motion, the property by virtue of which continue in its state of uniform motion is called inertia of motion. Look at this, if the mass of the body be large, so body has a greater tendency to remain in its state of rest or uniform motion. So mass is the measure of inertia. Look at this is a rubber ball and a steel ball. Both have same dimension. So mass of steel ball greater than the mass of rubber ball. So inertia of steel ball greater than the inertia of a rubber ball. Understood? When moving bus suddenly stopped, the passenger of the moving bus moves forward. When a bus suddenly accelerates, the upper portion of the passenger of the bus have a tendency of backward motion. Okay? Now the balanced and unbalanced force. First of all, balanced force. Look at this. If two or more forces acting on a body in such a way that net force acting on the body is 0. Look at this. Suppose this force F and this force F, these two forces acting into opposite direction on the body, the net force is equal to 0. These forces are called balanced force. Balanced force cause the change the shape of a body. If two equal forces acting on a spring, the spring get compressed. If two equal opposite pulling force acting on a rubber cord, the rubber cord get elongated. These are the example of balanced force. Okay? Therefore, balanced force cause the change the shape of a body. Okay? Now unbalanced force. Look at this. Suppose this force F1, this force F2 acting on a body. If If F1 not equal to F2, then this is called unbalanced force. If F1 greater than F2, then the body moves along this direction. If F2 greater than F1, then the body moves along this direction. So unbalanced force produces motion. Now momentum. The momentum of a body is the product of mass and its velocity. That is momentum P equal to mass into velocity. In SI system, the unit of momentum, look at this is the kg and this is the meter per second. So this is the kg meter per second, or it also called Newton into second. Okay? In Cbse system, its unit is gram centimeter per second or dyne second. Understood? Now change of momentum. Look at this, the change of momentum delta P, this is the P2 minus P1, so this is the mv2 minus mv1. If the final velocity is greater than initial velocity, the momentum is positive. Okay, if final velocity less than initial velocity, then change of momentum is negative. Look at this, momentum is a vector quantity. It has specific direction. Okay, understood? Now Newton's second law of motion. Second law of motion. The rate of change of momentum of a body is directly proportional to the force applied on it, and changes takes place in the direction of applied force. Look at this. Suppose this is a body. The force acting on it, F, directly proportional to rate of change of momentum, that is delta P by delta T. Look at this. This is the change of momentum, and delta P by delta T is the rate of change of momentum, and changes takes place, that is change of momentum takes place the direction in which force is acting. Okay, now from this law we can define the unit of force. Suppose a body of mass m moves with velocity u. After the time t, its velocity becomes v due to application of force F. Okay, due to application of force F. So look at this, its initial momentum is mu, and final momentum, this is the mv. So change of momentum in time t is delta p equal to, this is the mv minus mu. So rate of change of momentum, look at this, this change of momentum takes place in time t due to application of force F. So rate of change of momentum, this is the m into v minus u divided by t. Look at this is the change of velocity by time. So rate of change of velocity with respect to time is the acceleration. So this is the mass into acceleration. Now from statement of Newton's second law of motion, F proportionate, this is the dp by dt. So this is the m into a. So this is the F proportionate mass into acceleration. Therefore F equal to k m a, where k is constant. If a equal to 1, m equal to 1 and f equal to 1, then what is the value of k? Look at this, 1 1 1. So k is obviously 1. Therefore unit force produces unit acceleration of a body of unit mass. This is the definition of force. Okay, unit force produces unit acceleration of a body of unit mass. Okay, in Cbse system the unit of force is dyne. Therefore one dyne force produces acceleration of 1 centimeter per second square of a body of mass 1 gram. So 1 dyne is equal to 1 gram into 1 centimeter per second square. Now in SI system the unit of force is Newton. So look at this, Newton. So 1 Newton force produces acceleration of 1 meter per second square of a body of mass 1 kg. So 1 Newton, this is the 1 kg into 1 meter per second square. Look at this, 1 kg means 1000 gram and 1 meter per second square, that is the 100 centimeter per second square. So this is the 10 to the power 5 gram centimeter per second square. Look at this, this is the dyne, therefore this is the 10 to the power 5 dyne. This equal to 1 Newton. Okay, now another two units are used to measure the force. One is gram force and other is kg force. Look at this, 1 gram force means G into dyne. G into dyne means 980 dyne. Okay, and look at this, 1 kg, that is the G Newton. So this is the 9.8 Newton. These two units are called gravitational unit of force. Understood? As k equal to 1, so Newton's second law of motion, F equal to mass into acceleration. Okay? Now derivation of first law from the second law of motion. Look at this, from second law of motion we know F equal to mass into acceleration. If force acting on a body is 0, then this is the 0, so this is the m into a. Therefore m not equal to 0, therefore a equal to 0. If a equal to 0, that is change of velocity equal to 0, that is v equal to u. That is, if the body is stationary, it remain at stationary. If the body is in motion, so the body continue in its state of uniform motion. Therefore, from this statement we can say, if force acting on a body, then the body either at rest or uniform motion in a straight line. This is the first law. Okay, understood? Next, now the graph between momentum and velocity, that is PV graph. Look at this, P is the vertical axis and V is the horizontal axis. Look at this, as P equal to mv, so this graph is straight line passing through origin. Now here mass m equal to constant. Okay, now if we draw the graph mv graph, mass and velocity. Now if we draw the mv graph where p equal to constant, so look at this, this is the m and this is the v. So this graph becomes a rectangular hyperbola, that is m never be 0 and v never be 0, because when m 0, v becomes infinity. This is not possible. Okay, understood? Next, the graph between force and acceleration when mass is constant, that is, it is known as FA graph. Look at this, m constant. Okay, now look at this graph becomes also straight line because f proportionate a. Okay, because f equals to ma, so look at this, f proportionate a, so this graph is a straight line passing through origin. Now when force constant, the graph between m and a becomes, look at this, rectangular hyperbola. Here m equal to f constant equal to constant, so m inversely proportional to 1 by a, so this graph is rectangular hyperbola. Okay, in this case the acceleration or mass never be 0, because one is 0, other becomes infinity. This is not possible. Okay, understood? Now Newton's third law of motion. To every action there is an equal and opposite reaction. If force acting to first body is F and force acting on second body by first body is F dash, so here F equal to negative sign of F dash. This is the action and reaction. In our universe, the action and reaction are always in pair. That is, if action is present, reaction also present. Single real force never be present in our universe. Okay, and look at this action and reaction are always acting on two different bodies. Now what happens if action and reaction acting on the same system? Look at this, if the two particles are in the same system, then net force in the system F plus F dash equal to 0. So net force acting on the system 0, so no motion is produced. That is why we can't pull a chair by sitting on it. We can't push a car by sitting inside the car. Okay, now Newton's third law of motion from second law of motion. Look at, suppose two bodies are in same system. The action force acting one on two is F dash. In reaction, the force acting by 2 on first is F. So these are action and reaction. So net force acting on the system is equal to F plus F dash equal to 0, because no external force acting on the system. So net acceleration is also 0. So from Newton's second law of motion, force equal to mass, this is the m1 plus m2, this into 0. Therefore F plus F dash, this equal to 0. Therefore F equal to minus F dash. Therefore action is equal to negative sign of reaction. Understood? Now conservation of linear momentum. First of all, statement: if no external force acting on a system of particles, then their linear momentum are conserved both in magnitude and direction. That is, initial momentum is equal to final momentum. Now look at these two bodies of masses ma and mb are moving on the same line with velocity ua and ub. So their sum of initial momentum, this is the ma into ua plus this is the mb ub. After collision, their velocity becomes va and vb. So final momentum becomes, look at this is the ma va plus this is the mb vb. So here initial momentum equal to final momentum, because no external force acting on the system. Here two forces acting are the internal forces. So if there is no external force acting on the system of particles, then their linear momentum is conserved. That is, initial momentum is equal to final momentum. Understood? Now how can we prove it? Look at this. From during collision, the force acting on B by A is FAB, and force acting by B on A is FBA. So these are the action and reaction. So look at this. Here FAB, this equal to minus FBA. Look at this. The force exerted by A on B is the FB. So this is the rate of change of momentum. This is the MB into VB minus UB divided by time. This is the force. This is the force exerted by B on A. So look at this. This is the MA into the final velocity of A minus initial velocity of A divided by time. Look at this and this cancel out. If we multiply this, we can get this relation. Now look at this. This is the MB VB minus MB UB. Okay, look at this. This is the negative sign of, this is the MA VA plus this is the MA UA. Okay, now if this, now this is taken this side and this taken this side. Look at this. This is the MB VB plus this is the MA VA. This equal to, this is the MA UA plus this is the MB UB. Look at this. This is the final momentum is equal to initial momentum. Understood? Next. Now a recoil of gun. Before firing, both bullet and gun are at rest. So their sum of initial momentum is 0. So momentum of gun plus momentum of so momentum of gun plus momentum of bullet is equal to 0. Now after firing, the velocity of the bullet be small v. So its momentum becomes, look at this, this is the mv, and velocity gained by gun is capital V. So momentum of the gun is capital M, capital V. Look at this. This is the initial momentum and this is the final momentum. So these two momentums are equal. So from this relation V equal to, this is the mv by capital M. This is the negative sign. So as velocity of the gun is negative, so gun recoils. Okay, understood? Here mass of the bullet is less than mass of the gun. So velocity of the bullet is much greater than the velocity of the gun. So kinetic energy of the bullet much greater than the kinetic energy of the gun. Okay, many thanks for watching this video. This video will be extremely beneficial for you. Please like, comment and share the video. And if you are new, please subscribe my channel to learn physics easily. Okay.